Okay, hi guys. Today we're going to do elimination. We're going to use elimination to solve systems of linear equations. So we're going to use elimination to find that intersection point of two lines that are crossing. So elimination may be your favorite because it's not too different from a subtraction problem. It's kind of like taking two linear equations and subtracting them. One thing that you have to pay attention to when you subtract, notice I've added a 0 here, so I've got 14, I'm going to subtract 2 from it. But the reason I added the 0 is so that I have the 1s in the 1s column, and I have the 10s in the 10s column. But I mean, there's none for that one, but you get my point. So when I subtract, I don't mismatch and subtract from the wrong values. So of course, if we subtract this, we know we get 12, right? That's really what elimination is. The concept's pretty easy. So let's go ahead and take a look at the rules here. The rules for elimination then says that you need to first, just like we did up here, make sure that our columns are making sure our variables and our constants are all in the same columns. What's that mean? It means that when I line up these two equations, if we look at one here, notice I've got two linear equations. I want to line up the x's over the x's. I want to line up the y's over the y's. And I want to line up the equality sign, the equal sign, over itself and along with the constant over the constant. They all have to be exactly on top of each other in that same arrangement. If the equal sign was over here and not here, this would be wrong. Okay, I'd have the x's over the x's, the y's over the y's, I'd have the numbers over the numbers, but they wouldn't be in the same columns, right? The equal sign is out of order, which means that the x and or this y here in this number is not on the same side on the right side as the top one. So that's the first and most important thing that you want to pay attention to. If there's a mistake, that's usually one of the first ones made. From there, we've got to pick a variable to eliminate. Which variable are we going to pick to eliminate? The easiest one. And I'll kind of go through that as we go. We want to try to find the easiest ones. There are some easier ones than others. Is it terrible if you don't pick the right one? Nah, it's just an extra step or two. That's really all it comes down to. From there, we'll do the elimination. Sorry, I'm going to switch my color. From there, we'll eliminate. Now, eliminate is, there's two ways to think of it. I like to think of it as, and I know I said subtraction problem at the beginning. I kind of like to think of it as an addition. What I like to do is I like to get my two terms opposite, but negative. I'm sorry, opposite, same and opposite. I said that they're supposed to be negative, so that is the negative part. But I want to get them the same, equal, and opposite. And then I just add everything together. If you don't want to do that, you ignore this part, and you just get them the same, and then you subtract. The reason I don't like that is because to do the subtraction process you kind of have to do a distributive, a negative, right before you start each and every time. And sometimes we mess that up. And it's one mistake that I can take out if I just deal with it when I get them the same and opposite. So that's the way that I'm going to approach it. Some people like to look at it as a subtraction. So if you see that, it's not wrong. It's just a different way to look at it. Finally, we're going to substitute in whatever coordinate we get. So if we get x, we'll substitute in for y. If we get y, we substitute in for x, or whatever variables they give us. And then finally, we get our coordinate point, and it should be a coordinate point. All right, so let's see that in action. Here's a nice easy one because it's set up for us. The couple first steps that we have to pay attention to are done for us. What do I mean? One, the x's are over the x's, the y's are over the y's, the equal signs are over the equal signs, and the constants over the constant. You should always start by looking for that. If that's not the case, rearrange it. Okay, so now that we have that lined up, next thing we have to pay attention to is that we have the equal and opposite signs. So I'm going to pick the negative 6y here and the positive 6y. Why? Because they're equal and opposite. And if I think of them as an addition problem or subtraction problem, if I do subtraction, this becomes negative, and then we have to change stuff. So I'm going to think of it as an addition problem this time, right? These two, your goal, regardless addition or subtraction, should turn into 0 if I combine them. So if I take a negative 6y and I combine it with a positive 6y, I get 0. That's your goal. You should have something turn to 0. Let me say that again. Look over here at B. Let me shrink this down. Look over here at B. Again, look, 6x, opposite of 6x, negative 6x. They must turn to 0. You have to get rid of one of the variables, otherwise you can't solve it. So your goal is to make one variable turn to 0. In this case, we chose the y. So we're going to finish this problem by doing the rest of the columns. So 5x and 3x make 8x. And negative 32 and positive 48 gives me 16. Drop down your equal sign, and I get a 16 there. So from here, that's pretty simple. 8x equals 16. Yeah, I can solve that. Divide by 8. X equals 2. Okay, that's the elimination part. Now elimination is done, and we go to evaluation. It's a substitution to evaluate, whatever you'd like to think of it as, but I'm going to take, and I'm going to switch my color here, I'm going to take this 2 now. I know it's equal to x, so I'm going to replace it somewhere up here. Doesn't matter which one, we'll go into the top one. How's that? I'm going to replace that x there with this 2, so I'm going to rewrite this equation, and I'm going to replace it with a 2. So I'm going to get 5 times 2, remember use parentheses for substitution, it preserves your multiplication, minus 6y equals negative 32. Here's a check at this point, make sure you only have one variable. Yep, just a y, we're on pace. So I get 10 minus 6y equals negative 32. I'm going to move this 10 to the other side, subtract 10 to both sides. Remember, reverse order of operations, do your addition, subtraction first, then your multiplication, so deal with the 6 after, right? By inverse operation, don't forget that. Those turn to 0, so they drop out. That negative comes down. Don't lose that negative. And we get negative 42. Divide by negative 6. Divide by negative 6. And you find out that we get 7. So I take my 2 coordinate points. X equals 2. I take my y value, which I didn't write down, but there's my 7. 2 negatives make a positive. And there's my coordinate point. Not too bad. You guys are getting pretty good at this. And this part, on the surface, for what it is, isn't difficult. So you should be able to handle this. Where does the difficulty come in? I'm going to put this over here real quick. Here, that way you could pause, copy those notes down, make sure you get all your notes. This is where it gets a little trickier. It's still not difficult at this point yet. Not anything you can't do. At this point, what we've looked at here, we got 2 linear equations, right? 2x plus 5y equals negative 22, and 10x plus 3y equals 22. There's your 2 linear equations. But you'll notice this time that our y's aren't the same and opposite, and our x's aren't the same and opposite. So at this point, pick the easiest one. I need them to be the same. Well, 5 and 3, if I have to get those to be the same number, the closest one I can get is 15, and I have to multiply both terms to get there. But if you look closely, oops, you know what we forgot to do? We're going to go back and do it right now. Is x's over the x's, y's over the y's, equal sign over the equal sign, numbers over the numbers. You have to check that first. Don't assume it to be ready. In the next example, it's not. Okay? So back to what we were doing. X's over x's. Now, look, this x here could easily become a negative 10x. How? Well, I'd have to multiply it by negative 5. If I do that, I have to multiply each part, right? Each part of the equation. If I only do a portion of it, I change it. I don't want to do that. So I'm going to multiply each part there by a negative 5. I'm going to rewrite it underneath. I'm going to change my color so you can see it. We'll use green now. So negative 5 times 2x, negative 10x. That's what we want. There's our 0. You can see it happening. Negative 5 times 5y, negative 25y. And then my equal sign drops down. It's over equal sign. And 22 times 5, what do you get? 110, negative positive 110. Okay? Draw my line. All right, so let's go ahead and do this addition problem, because it is addition at this point, because we have the same and opposite. So again, 10x and a negative 10x, there's our 0. That's exactly what we want. Let's finish the columns then. 3y and a negative 25y become a negative 22y. Equal sign drops down. 22 plus 110 gives me 132. A quick division of 22 will clean this up, a negative 22 at that. And if you plug this into your calculator, you should be happy to find that that becomes a negative 6. So y becomes a negative 6. Be very careful. We did not find x. We found y. Why is that important? When you're in a hurry, guess what you're going to do? You're going to pretend that's x because it's the first thing that you want to solve. But this case, we dropped x out. It became 0. So just watch yourself. When you go to plug this back in, I'm going to model my work over here. It looks like I plugged it into the first one. When I plug this y back in, right here, this is what I get. 2x minus or plus 5 times negative 6 equals negative 22. And you can see I worked all the way out. I get with a 4. There's my solution as a point. Okay, again, you can see we could possibly get some scary numbers here. In the next one, you should see us work with those. I'll pull this over so you can see B a little bit. I'll let you pause if you need to write that down. There you go. So now let's go down here to the most difficult scenario of this. Does it make it hard? No, just makes you mind more things. So first thing we got to notice is that these are not lined up. Look at this, right? I don't even know. We've got to shoot that one over a little bit. That one's got to come over here a little bit. So we've got x's over x's, equal signs over y's, 14's over equal signs. It's just a mess. So we need to rearrange one of these two. It doesn't matter which one. Just have to pick one. Well, let's just move this 3y over. So I'm going to add 3y to both sides. Now I need to make sure that this y is in the same spot on the same side. So on the right side I've got a number and then a negative y. So I'm going to keep this a negative 8 in front. And I'm going to put this positive 3y at the back. I'm going to rewrite the whole thing. So I get 7x equals, because these turn to 0, right, equals negative 8 plus 3y. I'm going to go ahead and transfer this down and rewrite it underneath because I like to have them close together when I do this so that they're right there. I can make sure that I eliminate any possible mistakes that I may get. So now I've got it all lined up. All right, so that's first. Check it. Lined up, lined up, lined up, because those are our constants and our y's are lined up. So everything at this point's lined up. I'm going to clean those out of there because I got an extra piece of work to do here. Now, you'll notice that our x's are not the same and opposite, or our y's. So what's the easiest way to go about this? Well, to get 7 and 4 to be the same, the smallest number I could probably get is 28, it looks like. I don't think I can get anything closer, but 3 and a 27, those are a multiple of 9 somewhere along the line, so I'm going to go ahead and multiply the top one by a positive 9 because this is already negative there. So again, I'm going to distribute. At this point, this becomes the routine. Nothing's different. You've already handled the elimination. Elimination, check. You're done with that. This is just your solving techniques taking place from here on out. So it may get ugly. Oh, I agree. But this is nothing that you haven't or shouldn't be able to do. So 9 times 7, we get 63x equals 9 times negative 8, which is a negative 72, and 9 times 3, which gives us our positive 27y. I think I erased a y there. That should be a y, right? So now we can draw our line. These are going to drop out, right? Let's clean up the rest of it. 4x and a 63x give me a 67x. This equals, what do we get? 14 and a negative 472 gives me a negative 58. Okay, so let me change colors so that's getting hard to see. I'm going to divide by, now I'm going to write over the words here. You'll have to bear with me. Sorry about the amount of room I've got here. Divide by 67 on both sides. Those reduce to 1. So I'm left with x equal to negative 58 divided by 67. Does it reduce? You can check it. I'm pretty sure it doesn't. If it does, I missed it. So that's the number we have to deal with. Is it wrong? No. If you get an ugly number, is it wrong? No. You have to deal with whatever comes out. You have to be confident enough to know that, hey, those are the numbers. I did all my steps right. What do we do with it? The same thing we did before. Nothing changes. Just because it's ugly doesn't mean we don't deal with it. I'll look over here at my previous work. It looks like I plugged it into the bottom equation. I have an x coordinate, so I'm going to plug it in for x. It goes right there. And then you'll see that this is where I start up at, right? So 7 times negative 58 67ths equals, looks like I plugged it into the one that I changed. So I used this one here. Which you shouldn't do. You should always go back to the original. That was a mistake on my part, but we'll go with it. And you can see my work from there. I'll let you pause as you need necessary. Multiplying by 7. Again, changing it 7 over 1. Numerator, numerator. Denominator, denominator. I've got a fraction of negative 406 over 67. Very viable. Add 8 to the other side. What's that mean? Well, I've got to combine 8 and negative 406 over 67. Yes, that does have to happen. It has to stay a fraction. Multiply by a fraction of 1. I get 536 over 67, so I'm combining 536 and negative 403, which gives me 130 over 67. There's my 3y. At this point, I'm dividing by 3 on both sides. And remember, division of 3 is the same thing as multiplying by 1/3. So I chose to multiply by 1/3. Thought it would be easier to deal with. Multiply numerators, multiply denominators. 1 times 130 is 130. 67 times 3 is 201. There is your nasty, gross numbered fraction solution that's correct. Will you have to do that? Absolutely. Can you do it? Absolutely. Is it more things to pay attention to? Absolutely. So take your time, work it out, get comfortable with your fractions. I have them in the room. Take a picture if you need that stuff. Pull up a fraction video from YouTube. Go to my YouTube channel. There's stuff in there. But if you need support for that, go find it. Don't quit. You solve this out however the numbers look. Okay? All right, so there's your notes. I'm done. A little longer, but still good part. So I'll see you in class.